Alright, here's one more technique for solving equations. This uses sum to product formula. Here's an example. I want to know when is the sine of 5x equal to sine of 3x. I mean, graphically, I see this in the following way. The sine of 5x, if you go from 0 to 2 pi, cut that into 5 equal pieces. 1, 2, 3, 4, 5 equal pieces. The sine of 5x is gonna, be your, it's gonna vibrate 5 times from 0 to 2 pi. The sine of 3x, on the other hand, is going to vibrate 3 times. So you cut this into 3 equal pieces, and you got, something that's going to look like this. And the question is, can you tell where they intersect? Certainly they cross, but where exactly? Now, I didn't plot this overly accurately. There may be some places where I can tell definitely they cross. Sometimes I can see, for instance, maybe they lined up the high point at the highest here, or right smack dab in the middle. They both have to be going through something. I didn't plot it accurately enough to see that, but I can see that certainly they cross a bunch of times between 0 and 2 pi. Okay. One option that I have is to use some formulas to break the 5x up into, say, 1x plus 4x, and use a sign of a sum, and then work on the 4x's to break those into 2x's, and the 2x's and x's. Write this all in terms of x, and write this side in terms of x. It would be big and ugly. However, I have another option. What I'm going to do is I'm going to bring this over to the other side and say I've got the sine of 5x minus the sine of 3x equals 0. And then I'm going to recall the sum to product identities. In particular, the sine of u minus the sine of v is 2 times the cosine of u plus v over 2 times the sine of u minus v over 2. Okay? This is one of our sum to product identities. The thing that I can do now is I can use that to rewrite the left-hand side of this equation, because the 5x is playing the role of u and the 3x is playing the role of v. So this left-hand side should turn into 2 times the cosine of 5x plus 3x over 2 times the sine of 5x minus 3x over 2, and this is equal to 0. Where I start with a difference of two numbers equaling 0, I now have a product of 3 numbers, 3 numbers equaling 0, and that's nice. Products equaling 0 give me simpler equations because one of the factors has to be 0. So simplifying this a little bit first, though, I've got 2 times the cosine. 5x plus 3x is 8x, and I divide by 2, that's 4x. And then I've got the sine of 5x minus 3x, that's 2x, divided by 2 is just x. That's equal to 0. So this equaling 0 boils down to that equaling 0. But this is factored, and I like that. So what I have is either 2 is equal to 0. Of course, it's not equal to 0. So the cosine of 4x might equal 0, or the sine of x might equal 0. Well, these are ones that I can solve. Cosine of 4x equaling 0. When is the cosine equal to 0? I have this, I draw a little picture down here just to look, and I say cosine curve, when is it equal to 0? That was 2 pi. So that was 2 pi. This is pi. So that must be the pi over 2's. So the odd pi over 2's. So it looks like 4x has to equal pi over 2 plus pi n. Usually with cosine I have to use 2 pi's, but because we're right smack dab in the middle, the gap from here to here is the same as the gap from there to there. So I can get away with just doing that. Solving for x then, x is pi over 4. Divide that by 4. That's pi over 8 plus pi over 4n. Right, so I divided the pi over 2 by 4, and I divided that by 4. Now over here, which I should point out, these are all the odd pi over 8's, right? Because this is 2 pi over 8. So this is 1 pi over 8, 3 pi over 8, 5 pi over 8, and then on the negative side as well. Over here, when is the sine equal to 0? Well, I'm looking at my sine curve thinking, when is that equal to 0? That happens on the pi's. So x equals pi n. So all of these, all of those are solutions to this equation that we started with up here. Okay. It's a powerful tool to be able to turn a difference or a sum into a product. I mean, you do it all the time when you're trying to solve quadratic equations. You get everything on one side 0, on the other side, and factor it. That factoring it is exactly this thing here, that you're turning a sum into a product. All right. So there you go. There's sum to product formula used to solve an equation.